Assalamu alaikum warahmatullahi wabarakatuh. You are welcome to the next edition of our online class from Islamic College Shogbo. This is chemistry for Ss3 students. Today, inshallah, we are going to start a new area of study, and that is solution to past examination questions from our main examination bodies, the WAEC and NECO. And the topics from which questions were sourced today include atoms, atomic structure, electronic configuration, periodic table, periodicity of elements, and so on like that. Inshallah, in order to be able to achieve this, we will look at certain background knowledge before we start looking at questions and their answers. The background knowledge, you start with the brief explanation on atom. An atom is the smallest particle of an element that can take part in a chemical reaction. Please take note of the words used. Smallest particle of an element that can take part in a chemical reaction, not smallest indivisible particle of an element, as some people want you to believe. So take note of that. Now, as far as an atom is, it is still made up of tinier particles. These tinier particles are many, but there are three common ones among them, which are called the three fundamental particles of an atom. These include protons, neutrons, and electrons. The protons and neutrons are found in the nucleus of an atom, and they constitute the mass number of the atom. The addition of number of protons and neutrons in an atom makes up the mass number of the atom, while the electrons are found around the nucleus. For an atom that is neutral, the total number of protons in the nucleus is equal to number of electrons around the nucleus. Since protons are usually positively charged and electrons are negatively charged, neutrons are neutral. So if the number of protons is equal to number of neutrons, number of protons is equal to number of electrons, that shows that the positive charges balance up the negative charges, and so the atoms are neutral. Electrons are outside the nucleus, therefore they can be easily lost, as well as other electrons can also be gained. So when an electron is lost from the outermost shell of an atom, the atom becomes positively charged because the number of protons will not be more than number of electrons. Take for instance, where you have an atom having 12 protons and 12 electrons. If 2 electrons are lost, you will be left with 12 protons and 10 electrons. That is, we have net higher number of protons, and that is net positive charge. So the number of electrons lost is equal to the magnitude of positive charge that will be carried. So in that case, it will carry a charge of +2. So similarly, if an electron gains electron, the number of electrons would have increased compared to the number of protons, and that means there will be net negative charge, because electrons are negatively charged and protons are positively charged. So if you have an atom that has 15 protons, 15 electrons, and you now add 3 electrons to it, then it means we are going to have 18 electrons, 15 protons. So the negative charge would have increased, and that will make the charge, the total number of electrons to now be 18, while the number of protons will be what? 15, and the atom will now become negatively charged with a magnitude of -3. So when you have an atom that possesses electric charge like this, we say that we have an ion. An ion is usually formed when an atom loses or gains electron. Positive ion when the atom loses electron, negative ion when the atom gains electron. The arrangement of electron around the nucleus, there are usually paths around the nucleus where electrons are most likely to be found. These paths are called electron orbitals. An electron orbital is the path around the nucleus where electrons are likely to be found. So these are some of the electronic configurations which are already aware of. This is electronic configuration of an atom that has one shell and one electron. This is another electronic configuration. 2 electrons in the first shell, 2 electrons in the second shell. That is 2, 2. Electronic configuration is 2, 2. Another electronic configuration, 2 electrons in the first shell, 3 electrons in the next shell. That is electronic configuration is 2, 3. Then you have another atom that has 5 or 6 electrons in the atomos shell. So the electronic configuration will be 2, 8, 6. So this is the KLMS method. But the electronic configuration can also be written in another manner using the SPDF method. If you are using the SPDF method, then you have the orbitals more easily defined. You have the S orbital, P orbital, D orbital, and F orbital. Maximum number of electrons that an S orbital can take is 2. Maximum number of electrons that P orbital can take is 6. Maximum number of electrons that D orbital can take is 10. Maximum number of electrons that F orbital can take is 14. You see that the number varies arithmetically with a common difference of 4. So for an atom like sodium that has 11 electrons, then the electronic configuration will be 1s2, 2s2, 2p6 and 3s1, following the order of filling electrons into the orbital, starting from 1s, 2s, 2p, 3s, 3p, 4s, 3d. For atom carbon that has a atomic number of 6, the electronic configuration will be 1s2, 2s2, 2p2, 2p2. For calcium that has 20 electrons, the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. And for argon that has an atomic number of 18, the electronic configuration will be 1s2, 2s2, 2p6, 3s2 and 3p6, as you can see on your screen. Now, from the electronic configuration of an element, it is easy to determine the group to which the element belongs or the period to which the element belongs. If you use the KLMS method of electronic configuration to determine the group, the number of electrons in the outermost shell is the group to which the element belongs. While using the SPDF method, there is another method of determining the group and the period. So let's look at the KLMS method first. Using the KLMS method, if you want to determine the group of an element, the first thing we have to do is to write the electronic configuration. After writing the electronic configuration, we will now look at the number of electrons that occupies the last shell. The number of electrons that occupies the last shell is what we call the valence electrons. Since the last shell is called the valence shell. Considering the example that we have looked at before, this atom has only one shell and there's only one electron there. It means there's only one electron in the outermost shell. So the elements can be grouped into group 1, even though we still have a lot of things to talk about that. This one has 2 shells, but this outermost shell, which is the valence shell, has 2 electrons, so it will be in group 2. Look at this atom. There are 3 electrons in the outermost shell, so it will be in group 3. Look at this atom. It has 6 electrons in the outermost shell, so it belongs to group 6. This is what we are saying. Now, From the atoms, from the electronic configuration, you can also determine the period of the element. The period of the element is the number of electrons, number of electron shells, rather, number of electron shells in the electronic configuration. Look at this atom, only one electron shell. So the period is period 1. There are 2 electron shells in this atom, so it belongs to period 2. 2 electron shells in this atom, it belongs to period 2 as well. And 3 electron shells in this atom, it belongs to period 3. But if you are using the SPDF method to determine the electronic configuration of, to write the electronic configuration of an element, we will consider number of electrons in the outermost orbital as well. Now, looking at number of electrons in the outermost orbital, we can determine the group. If the last orbital to be filled is an s orbital, the element will be referred to as an s block element. But if the last orbital to be filled is a p orbital, the element will be referred to as a p block element. For an s block element, the number of electrons in the outermost shell is equal to the group. So it means you can have group 1 and group 2 elements as s block elements, since maximum number of electrons an s block and s orbital can take is 2. So group 1 and group 2 elements are s block elements. But if the element is a p block element, the group will be the number of electrons, the last piece of energy level, plus 2. That will give us the group of the elements. Now let's consider the examples we have looked at before. Looking at these examples, in this case now we have sodium to be as 1s2, 2s2, 2p is 3s1. So the last sub-energy level is 3s, and it means this is an s block element. So the period will be, and the group will be group 1. So this element belongs to group 1. If you look at the next element here, the last sub-energy level to be filled is p. So it means this is a p block element. So the group will be 2 plus number of electrons in the outermost shell, that is 2 plus 2, that is 4. So look at the next one here. This is also an s block element because we have 4s here. So the number of electrons in the last 4s of energy level is 2. So the group is 4. Considering this one, the group will be what? This is also a p block element, so the group will be 6 plus 2, and that is 8. So it means belong to group 8. Group 8 is also referred to as group 0 because that is the group to which all noble gases belong. Now, as for their period, the period of an element when the electric configuration is written using the SPDF method can be determined by the highest coefficients in the electronic configuration. So sodium, according to that rule, belongs to period 3. Carbon belongs to period 2. You can see. Calcium belongs to period 4. And argon belongs to period 3. These are things you already know. Now, there are also certain areas that we need to look at. These are some of the atomic properties that vary within the group and period of the periodic table. Among the atomic properties that we are going to look at are atomic radius, ionization energy, electron affinity, electronegativity, and another one that we are able to talk about before we leave this class. The atomic radius of an element is defined as half the distance between nuclei of two adjacent atoms of the same element lying adjacent to each other. Half the distance of closest approach between nuclei of two adjacent atoms of the same element. In other words, what you are saying is that the atomic radius is the distance between the nucleus and the outermost electron. So it is just the nucleus of an atom. Just the nucleus of an atom. Look at this. So if this is an atom, so the atomic radius of this atom will be the distance between this and this. The distance between this and this. The atomic radius of this atom will be the distance between this and this. Atomic radius of this atom is the distance between this and this. And if this is an atom, the atomic radius is distance between this and this. So this is the atomic radius of the element. But because the radius of an atom cannot be directly measured, it is measured as distance between atoms of the same element that are lying adjacent to each other, and that is the distance between them divided by 2. That will just give us the atomic radius, and that's why it is defined as I have said before. Now, if you now have two atoms, because this is what we usually look at when we talk about the trend of certain properties within the periodic table. If you have two atoms like that are within the periodic table, for example, in a group, within a group, all atoms, all elements have the same number of valence electrons, and that's why we have said it. For elements to be placed in group 1, it means they must have one electron in the outermost shell. So within a group, all elements have the same number of electrons in the outermost shell. But there will be a difference, because when we leave from the top of the table to the next element, we will move to the next period. So if this is period 1, this will be period 2, and this will be period 3. So they have different number of electron shells. So within a group, the atomic radius, the radius of this one is smaller compared to that of this one, and the radius of this one is smaller than this one. It means atomic radius will be increasing than the group. This is how we come about the trend. Now, looking at across the period, that is from left to right, you will see it will seem that they have the same number of electron shell. So to any observer, it will seem as if they will have the same radius, but no, because the nuclear pool between the nucleus, which is positively charged, remember I said the nucleus contains protons and neutrons. Protons are positively charged, neutrons are neutral. So the nucleus is fundamentally positively charged. Between the nucleus, the positively charged nucleus and negatively charged electrons, there's a force of attraction, as you already know. Unlike charges attract. So that force of attraction is called nuclear pool. So the nuclear pool between the nucleus and the outermost electron. So as number of electrons increase, the nuclear pool also increases. So the nuclear pool here will be less than the nuclear pool here. So the nuclear pool here will be more, and therefore this atom will be smaller than this atom. So the nuclear pool here will be more than this. Therefore, the atom that has 3 electrons in the outermost shell will be smaller than the atom that has 2. So as the number of electrons in the outermost shell increases, the atom becomes smaller within the same group. And therefore, we say that atomic radius decreases across the period from left to right. So as we said for atomic radius, the same thing applies to atomic volume, atomic size, or whatever we say about atomic. So that is how that varies. And that is why whenever we are talking about atomic properties and we are talking about their trend, it is very easy to remember. So from what we have explained so far now, you have seen at least 2 things that determine the trend. The first one is the number of shells. There is increasing number of shells from top to bottom in the periodic table, and across the period, that is from left to right, there is increased number of valence electrons, which result into increase in nuclear pool or nuclear charge. So nuclear charge results into variation of properties. across the period and down the group. The third factor that also has to do with variation of atomic properties within the periodic table, either down the group or across the period, is screening effect, which has to do with the force of repulsion among electron shells. Now, the next property that is of importance is ionization energy. Ionization energy is the energy required to remove the most loosely bound electron from the outermost shell of from the outermost shell of an atom or an ion in its isolated gaseous state. The first ionization energy is the energy required to remove the most loosely bound electron from the outermost shell of an atom in its isolated gaseous state. Now, how do we explain the trend of that one? The trend of that one, look at, you have to come here again. Look at these atoms. I want to remove this electron from this atom. Remember, this atom is very close to the nucleus, which is oppositely charged. So there is strong force of repulsion here. But when you compare this, the distance has increased, so the force of repulsion has reduced. The force of attraction has reduced. If you look at this one, the distance has also increased again, so the force of attraction has also reduced. It means it is easy to remove this electron. It requires less energy. To remove this electron, we require more energy than compared to this one, and to remove this electron, we require even more energy compared to the one. What happens there? It means as we go from the top of the table to the bottom of the table, the energy required to remove the electron is reducing, and the energy required to remove electron is what we call ionization energy. Therefore, ionization energy decreases than the group. Let's look at around the period. We have said this atom is bigger than this atom. This atom is also bigger than this atom. So as we go across the period, the atom reduces, meaning that the electrons come closer to the nucleus, and therefore from the principle we have just mentioned, it will be the energy required here will be less compared to the energy required here and compared to the energy required here. Therefore, ionization energy will increase across the period. So it decreases down the group, increases across the period. Across the period is also called from left to right, as I have said before. So that is that about that property. Considering the third property, electron affinity. Electron affinity is the energy required, or the energy with which an atom will attract electron to itself in its isolated gaseous state, or the energy required for an atom to attract electron to itself in its isolated state, or the ability of an atom to attract electron to itself in its isolated gaseous state. Now, if you still come and look at our hypothetical atoms, all of them wants to attract electron to themselves. So the smaller the atom, the closer the nucleus to the surrounding, and so the more the nuclear pool with which it can attract electron from outside. Therefore, we still look at the atomic size again. So the bigger atom will require will not be able to attract electron to itself compared to the smaller atom. So if you look at it from here, this atom is bigger than this. This is bigger than this. Therefore, this will attract electron to itself, but not with as much force as this. And this will attract electron to itself, but not with as much force as this. Therefore, the force with which atoms attract electron to themselves increase across the period. and that means ionization energy increases across the period. Compared to down the group, this is smaller, and this is smaller. This is bigger than the first one, but smaller than the third one. So it means as we move down the group, we have bigger atoms, and therefore less energy with which they will attract electrons to themselves. It means ionization energy decreases down the group. So if you are able to understand the size issue, you can easily understand the trend and the trend of the atomic properties. Coming to electronegativity. Electronegativity is defined as the ability of an atom in a molecule to attract electron to itself. Please take note of that difference. When we are talking about electronegativity, we said that ability of an atom in its isolated gaseous state to attract electron to itself. But now that we are talking about electronegativity, we are talking about ability of an atom in a molecule to attract electron to itself. It means when we have two atoms together within a molecule, each of them wants to, especially when covalent molecule is formed, each of them want to have the share of the electron. So the two atoms will be dragging the electron with themselves. But the ability of each of them to drag the electron towards itself is what's called electronegativity. And it has the same trend as electron affinity, as you would agree with me from the analogy we have been given this morning. Because we don't have much time, I hope you understand that. Now let's look at some of the questions that we have here. Question 1. We have it here in the periodic table. The arrangement of elements according to their what? So you have the options there: oxidation number, atomic number, mass number, and number of neutrons. It is obviously the atomic number. It's the atomic number that we use in arranging electrons to arrange elements in the periodic table, because it's the atomic number that will give us the electronic configuration with which we are going to determine the position of elements in the periodic table. Question 2. In the periodic table, calcium and magnesium belong to which group? At least you agree with me that the electronic configuration of calcium is 20. It's even one of the elements that we wrote in the electronic configuration. Magnesium, the electronic configuration of magnesium, the atomic number of magnesium is 12. Atomic number of calcium is 20. So if you write the electronic configuration of calcium, we are going to have 4s2 as the last orbital. If you write the electronic configuration of magnesium, we are going to have 3s2. It means both of them belongs to group 2. So one belongs to period 3, the other one belongs to period 4. But both of them belong to group 2. So the question is asking us for what is common to the two of them, and it is their group that is common, not their period. Now look at the next question. Elements in group 7 are called what? Or are known as what? They are known as halogens. Halogens. And that is option C, as you can have it in that question. Coming to the next question. In the periodic table, electronegativity what? Decreases across the period and down the group. Decreases across the period but increases down the group. Increases down the group and down the period. Increases across the period but decreases down the group. Increases across the period but remains constant down the group. Definitely we know that the trend of any of the atomic properties is not the same thing across the period and down the group. So those ones that are saying similar thing for both across the period and down the group are already eliminated. Like option A is eliminated, option C is eliminated, and then it is not constant anywhere, so option E is also eliminated. So we are left with option B and option D. Now let's now look at them critically. Electronegativity decreases across the period. So we have said it. If you look at our hypothetical case, you see that electronegativity increases across the period but decreases down the group. So the correct answer to that question should be electronegativity increases across the period, decreases down the group, and that should be option D, based on the analogy we have been given since we started this lesson. So the next question: chlorine ion and chlorine atom have the same what? what is, that is the question is trying to ask us what is similar between chlorine atom and chlorine. So, do they have the same chemical property? No. No ion of an atom has the same property, chemical property, as the atom itself. Electron charge, no, because atom does not have any charge, zero. The charge of atom is zero. The charge of an ion is, in this case, is -1. So they cannot have the same electron charge. Electronic configuration, no, they cannot have the same electronic configuration as well, because number of electrons are not equal. And the electronic configuration has to do with number of arrangement of electrons around the. So number of electrons, no. So option C and option D are essentially similar. So number of protons, yes, because they have the same number of protons. Number of protons does not change when an atom becomes an ion. It's the number of electrons that change. Now, next question. Which of the elements has the highest ionization energy? Which of the elements has the highest ionization energy here? Now look at the options. You have calcium, chlorine, fluorine, and magnesium. Definitely, since we have agreed that ionization energy increases across the period, it means those elements that that belongs to higher groups, we have higher ionization energy. So the metals are eliminated. Calcium and magnesium belong to group 2, so they cannot have the highest. But chlorine and fluorine belong to the same group. That is group 7. So both of them we have higher ionization energy compared to calcium and magnesium, which are metals, which have low ionization energy generally. Now, but between chlorine and fluorine, which one we have higher ionization energy? If you look at chlorine, chlorine is smaller than chlorine. So it means chlorine is higher in the periodic table than chlorine. That is, and we have ascertained that electronegativity. Subhanallah. No, what the question is asking us, which of the elements has highest ionization energy? Ionization energy, not electronegativity. Highest ionization energy. Now, ionization energy, we have also agreed that it increases across the period, decreases at the group. They have definitely, all metals usually have low ionization energy, but non-metals have higher ionization energy. So those ones that are at lower group have low ionization energy, but those that are at a higher group have higher ionization energy. So, but chlorine and fluorine are in the same group, but ionization energy increases across the period, decreases down the group. So it means those ones at the top, we have more ionization energy than those at the bottom. And since fluorine is usually above chlorine in the periodic table, since fluorine is smaller than chlorine, so fluorine has higher ionization energy. If you go back to the analogy that we have just given concerning these terms, you would agree with me that the correct answer there is C. Now, next question. The group to which an element belongs in the periodic table can be determined by the number of valence electrons, not valence shell. The period is what is determined by valence shells, but the group is determined by valence electrons. That is number of electrons in the outermost shell. Not number of electrons per se, but number of electrons in the outermost shell. So it is, the option should be option D. Then what is the electronic configuration of the element with the atomic number of 17? So we have 17 electrons to share, and we have the we know the order by which we have to write the electronic configuration. 1s, 2s, 2p, 3s, 3p, and so on like that. So option A is obviously correct. The other options are wrong. Option B is wrong because the number of electrons there is not complete. Option C is wrong because we cannot jump from. We have 1s, 2s, 2p, 3s, 3p. We cannot jump from 3p to 3d and to 4d. So from 3p, the next is 4s. And besides, if you look at the number of electrons here, it is more than 17. And then if you look at D, option D is also wrong. The number of electrons here is more than 17. This will be 18 electrons. And option E, the number of electrons is not complete. So it is only option A that is right. So next question. The valence electrons of magnesium, that is Mg, with atomic number of 12, in the dash orbital. So if you write the electronic configuration of magnesium, you are going to get 1s2, 2s2, 2p6, 3s2. So the valence electrons are in the 3s orbital. So the correct answer is A. Next question, question 10. Which of the following electronic configuration represents the transition element chromium? Chromium with the atomic number of 24. If you write the electronic configuration, you will discover that the electronic configuration will end with 3D. So it will end with 3D4, and that is option C here. 1s2, 2s2, 2p6, 3s2. No, this is wrong. So option C is wrong there, because this is 4s1, 3d4. So option C is wrong. So option A is the correct answer. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. That is the correct option. So option A is the correct answer for that particular question. Looking at question 11, the atomic number of an isotope of hydrogen is equal to its mass number, because it's now if the atomic number should be equal to the mass number, remember we said that mass number minus atomic number will give us number of neutrons. So it means if the mass number is equal to atomic number, it means there is no neutron, because mass number minus number of proton will give us 0. So it means it contains no neutron, or does not contain neutron. That is option C, which is the correct answer. Next question is question 12. Next question. Atomic orbital is what? A, the circular path through which electrons revolve around the nucleus. A region around the nucleus where electrons are most likely to be found. The path, we have defined it before. So the correct answer is region around the nucleus where electrons are most likely to be found. All other definitions are not correct. The path around the nucleus through which electrons move is not correct. The path around the nucleus through which protons move is not correct. So the correct answer is a region around the nucleus where electrons are most likely to be found. That is what is called atomic orbital. Next question. The property of elements which increases down the group in the periodic table is. So that is what this question is saying, that which of the following properties increases down the group. Definitely electronegativity does not increase down the group, it decreases. It increases across the period. Electroaffinity has the same trend with electronegativity, so it cannot be the correct answer. Ionic radius is not the correct answer. Ionic radius, okay, we also increase down the group, yes. Ionic radius is the correct answer, because we are talking about radius of the ion. So it's the correct answer. So ionization energy also has the same trend with electronegativity. So ionic radius is the correct answer. The correct answer here is option C, ionic radius. Which of the following arrangements indicates the correct order of decreasing of ionization energy of period 3? It means if you bring out all the elements in period 3, which are sodium, aluminum, phosphorus, and chlorine, which one we have the highest ionization energy, and which one will be next, which one will be next, which one will be next? That's the question. Now, looking at them now, evidence in period 3, ionization across the period, ionization energy increases. So it means the group 1 elements will have the lowest ionization energy, followed by group 2 elements, and so on like that. So option A cannot be the correct answer. So because when they say decreasing order, what they mean is that we should start from the highest. We start from the highest. So option A cannot be the correct answer. Look at option B. Yes, option B looks like it, because we have the group 7 elements, group 5 elements, group 3 elements, and group 1 element. So that should be the correct answer. So option B is the correct answer. Next question. Which of the following has the strongest metallic bond? The strongest metallic bond. And that is, which of them is the strongest metal? That is, has the strongest metallic property. So look at this. We have potassium, which has the large atom, 3 shells. Aluminum, which also has a large atom. So potassium has 4 shells. So aluminum has 3 shells. Magnesium has 3 shells. Sodium also has 3 shells. So definitely the one that has 4 shells cannot form metallic bond as strong as those ones that have 3 shells. Now among those ones that have 3 shells, which one we have the strongest? The one that is smallest among them, and that is sodium, as we have explained before. Now next question, which is number 19, which is the second to the last question here. Ionization energy is affected by the following factors, except distance of the outermost electron from the nucleus, size of the positive nuclear charge, ability to attract shared electrons, screening effect of inner electrons. Ionization energy. Let's look at the distance of the outermost electron from the nucleus. Does it affect ionization energy or not? Yes, it does. Because the closer the atom, the more the ionization energy. And the further the electron, the less the ionization energy. So it affects it. Let's look at option B. Size of the positive nuclear charge. Yes, it affects it. So the more the charge, the stronger the ionization energy. So it's affected. Option C. Ability to attract shared electrons. No. Ability to attract shared electron is basically that of electronegativity. That of electronegativity. So the screening effect also has effect on ionization energy. So the correct answer there is option C, which does not affect it. Question 20. The following atoms of carbon 12, carbon 13, and carbon 14 can be described as. So when you have atoms that have the same, that have different mass numbers like this, then we call them isotopes. So all of them are carbons, but different. So they are isotopes, not allotropes, not isomer, and not isotopes. So they are isotopes. The correct answer there is option C. Please go through the questions again and study the answer together with the preliminary discussion that we have done before. And let me know if there's any challenge you encounter in your solution. The better grant you understanding of the lesson. Assalamu alaikum warahmatullahi.